In this mini lecture for Module 7, we're looking at hypothesis testing and two-sample designs. Specifically, we're going to be looking at whether or not an analysis should be paired or independent. So if it's paired, it would be a paired sample t-test or a paired t-test, and if it's an independent analysis, then it would be a two-sample t-test. So this first example is looking at clinical interest in vitamin C preventing the common cold, and there's a study with 20 volunteers, and 10 individuals are randomly assigned to receive vitamin C, and 10 individuals are randomly assigned to placebo capsules. And then the number of colds over a 12-month period is recorded. So in this case, our independent variable is our different treatment, so are they receiving vitamin C or placebo? And our response variable is the number of colds over a 12-month period. Now for this type of analysis, think about if it's independent, therefore a two-sample t-test, or if it's paired. The answer here is that it's independent. And it's independent because there's no linking together the volunteers and whether or not they're randomly assigned to the vitamin C or the placebo. There's no linkage between vitamin C and placebo, so there's no reason to pair these individuals at all. Therefore, the appropriate analysis would be a two-sample t-test. For the next question here, we're looking at ophthalmology and spherical refraction between the right and left eyes. So refraction is measured in the both eyes of 17 people. In this case, think about what our independent variable is and our dependent variable or our response variable. So our independent variable here is which eye we're looking at, and the dependent variable or the response variable is refraction. Now, is this paired or is it independent? Is there any way to link together the left and the right eyes? And there is, so it's a paired analysis because each individual is having their left eye and their right eye measured. By doing that, we're controlling for things like genetic variation among individuals, because with one individual, they're going to have the same genetics, and we're measuring their left eye and their right eye. So we would then look at the difference between those and do a paired analysis. In this third example, we're looking at working environments where smoking is permitted and where it's not permitted, and the measurements that were made were at 2 p.m. in 40 work areas where smoking was permitted and 40 work areas where it was not permitted. So is this paired or independent? This is independent because there's nothing to link these two work areas together. Even though the measurements were made at 2 p.m., that's just controlling for, time of day factors. But those where there's smoking and there's not smoking, there's no way to link those unless, of course, there was businesses in the same building, or that worked in the, you worked for the same company and there was smoking in some parts of it and non-smoking in other areas, and then you could do it, between companies if that was controlled for. But the way that this is presented, it is independent. The fourth question is looking at nutrition research in male college students and asking if they have weight changes during their freshman year. And so there was a data file with data from September 94 and May 95, and you can see some of the examples for the records here. And so given this information, would this be paired or independent? So in this case, it's paired. So you can see that the file is set up so that each record contains the data for one student. So it's paired by student because their measurements are taken in September and then again the following May. Again, this allows us to control for, their lifestyle, for genetics. Students' metabolism might be different, so we do a paired analysis, and that would be stronger than just measuring data from a bunch of individuals in September and then getting a different group of individuals the following May if we want to look at weight gain and weight changes. And the last example that I have here is determining whether cardiologists and pharmacists are equally knowledgeable about how nutrition and vitamin K affect anticoagulation therapy. And so this research study was designed with 10 cardiologists and 10 pharmacists with a questionnaire And so she contacted administrators at 10 hospitals and asked them to select both a cardiologist and a pharmacist at random to complete the questionnaire. So is this independent or is this paired? Is there some way to link together the cardiologist and the pharmacist? And there is a way to link the cardiologist and the pharmacist because they're paired by hospital. So both a cardiologist and a pharmacist were chosen. Again, this would be a stronger design than having just 10 random cardiologists and 10 random pharmacists, because this way we can control for the hospitals, because maybe there's a difference in ongoing training and workshops available at different hospitals, because the real question of interest here isn't about differences between hospitals, it's differences between cardiologists and pharmacists. And so they want to know if they are equally knowledgeable. So that concludes this set of examples for this mini lecture.